Hi Year 11s, sorry that I wasn't able to book the computer labs today. They were booked out by the time I went to book them. So you're going to be doing a lesson today on significant figures and scientific notation. And then next week I'll make sure to book the computer rooms earlier so you can get your assignments finished. Okay, let's look at significant figures today. This is a tricky topic that a lot of people struggle with, but we use it when to round to different numbers, and we use it a lot in measurement. There's a lot of questions. It's often something that comes up in the HSC as a little side topic. So there might be an area question, and then you need to round to a certain number of significant figures. So you do need to know what you're doing with this one. Okay, I would like you to write out this summary for me, just so that it sticks inside your brain a little bit more. The first significant figure in a number is the first non-zero digit. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. They're all non-zero digits. When rounding to significant figures, you need to start counting from the first non-zero digit, basically. If it's a large number and we're asked to round to a significant figure, sometimes we have to insert zeros as placeholders. So if I was having to round something to, if I had to round 1,250 to one significant figure, then I would need to keep those zeros in there and it would be 1,000. Zeros at the end of whole numbers or at the beginning of a decimal are also not significant. There are a few catches here and I'll go through them when we look at some examples. Okay, so the first one we need to do is round 3,812.4 to two significant figures. The first two, so there we have all of these numbers here are non-zero digits, so none of these are zero. So the first two, we've got 3 and an 8. They are the first two significant figures, and that's what I need to round to. So A would be 3,800 as a significant figure. Okay, the next question asks us to round 1,005 correct to three significant figures. Now this one here is the first number we come across and it is significant. Now any numbers after a non-zero digit, so any zeros, they're significant now, especially if they're between two non-zero digits. So this first zero and second zero, they're significant now. So the 1, the 0, and the 0 are significant. Now this 5 rounds the 0 up to 1. So my solution is going to be 1,010. That is rounding 1,005 to three significant figures, 1,010. The last one here, round 0.003572 to two significant figures. Now these two zeros here aren't significant, so I'm going to ignore them. So the first two numbers that I'm looking at are the 3 and the 5. They're significant, but after that those numbers aren't significant, they're too small. Now we've got a 7 here, so that rounds the 5 up to a 6. So for C it would be 0.00. I still need to keep those zeros in there because they need to hold the place of the other numbers. So 0.0036. And that's my solutions. It can take a while with significant figures to get the hang of it, so my suggestion is to go and have a practice and then perhaps either re-watch this video or have another read of the textbook. Let's go on to scientific notation. Scientific notation is a shorthand way of writing very large or very small numbers using the power of 10. Scientific notation has the form of a number times 10 to the power of x or another number. So A is a number, it can be a decimal, between 1 and 10. So this first number particularly needs to be a number between 1 and 10. So I couldn't have 25 times 10 to the power of 3, for instance. It would have to be 2.5 times 10 to the power of 4. X is an integer, so x is any number. Just quickly, if A is a negative, then the number must be a decimal. This will make more sense when we go into practicing it. Okay, first example. Write each in scientific notation. So what I need to do is I need to convert this into a whole number, or a number with a ones unit, and then everything else is a decimal. My decimal would be sitting here. What I'm going to do is I'm going to count how many times I need to move my decimal in order to get it to this point here. So I need to go once, twice, 3 times, 4, 5, 6, 7. So I've had to move my decimal point 7 units, and it's been in this direction, so it's been in a positive direction. So my solution is going to be 2.35 times 10 to the power of 7. Hang on. Whoops. Why didn't this let him? Sorry, technical issue there. So 10 to the power of 7. So that should be 2.5 as well. So 2.35 times 10 to the power of 7. Okay, B. Here we have 0.004762. Now again, we need to make that a whole number. So we're going to have to move our decimal point a few spaces to the right to place it here. So again, we have 4 point something. So how many times am I moving that? I'm moving that 1, 2, 3, and that's 3 spaces downwards. So my solution is going to be 4.762 times 10. Sorry there. 4.762 times 10 to the power of minus 3. Now that's because we were going down, we had to move the decimal point down. In this one here, in A, we had to move it up, so that's why the 7 is positive. On the flip side, sometimes we'll be given a number in scientific notation and we need to convert it back to its original form. Now this one here is 6.92 times 10 to the power of 4. So that's telling us that they've moved that decimal place 4 places up. So what we need to do is move it 4 places back down. So it would be, let's move this decimal point 4 places back. So we're going 1, 2, 3, 4. So I'm going to need a 0 here, and I need a 0 here. So my solution is going to be 69,200. Okay, in my other example, I have 3.716 times 10 to the power of minus 5. Now this minus 5 here tells us that the decimal point has been moved down, so we need to move it back up. So we need to go 5 places up. So 1, 2, 3, 4, 5. That's where the decimal point needs to go. So we need a 0 here. So we need 1, 2, 3, 4 zeros before we put in the rest of our digits, our numbers. So 0.1234 3716. And that's how we convert scientific notation back into standard numbers. Today in class, you need to complete exercise 603, questions 1 to 4, and exercise 604, questions 1 to 4. Now, I will be looking on Monday to make sure that you have completed this set work, and I will be disappointed if it is not. And like I said on the whiteboard at the back of the room, there will be detentions for those who don't complete their set work. Sorry about not being able to book the computer rooms today. We will definitely have some time next week in the computer rooms to do that, and you can ask me any questions you need to at that point. Alright guys, I'll see you later.